Hello viewers and my dear students. Welcome to session 2 of problem 3, that is demo on CNC manual part programming for a basic milling profile involving contouring and rectangular pocketing using Demo-Fanuc Milling Simulation software. This is session 2, and as you are aware, in session 1 I clearly explained how exactly the programming has been made for this profile. That means in the session 1 I clearly explained how programming, that is manual part programming using G&M codes have been written for this profile, that is contouring, as well as this is contouring. This is all called contouring. Okay, circular contouring and linear contouring and all that, or profiling, linear profiling or circular profiling and all that. Profiling as well as rectangular pocketing, how the manual part programming has been made, I have already explained. This I have told you. See here, I have written, that means I have taken the coordinates 0, 0, 60, 0, 60, 60, 0, 60, A to B, B to C, C to D, D to A to B is G03 arc, B to C also G03, C to D G03, D to A is G03, and depending on the radii and all that you manage. This program I have already written. Okay, and also I have talked about rectangular pocketing also. See here, this I clearly given the program. Okay, tool going to point B, tool going to point C, D, A, and here and all that you see G03, X60, Y0. This is radius 50, this is radius 60, this is radius 50, this is radius 60. In that way, I have gone radius 50, 60, 50, 60. I have given clear explanation and all that. This is the program. Okay, now also I have clearly explained how the rectangular pocketing has to be done, and I have called the pocketing tool, and the speed is 1000. G90 is again absolute reference, all from the point A we have calculated all the dimensions, and G71 172, I40 J30, that is length and breadth of the pocket, K is corner roundness, P0 is it's a roughing cycle, no P1, it is only a roughing cycle. That means since it is Z minus 6, first it will cut minus 2, then minus 4, minus 6, without any alliance on the sides or the base. Okay, G173, I0 cannot means no alliances are there, 0, K0. P75 I have told you is cut width percentage, that means between successive parts of the tool there will be 25% overlap. Okay, and all these things I have told you, S1000 and all that. S1000 is, I have told you, S1000 is roughing spindle speed, R75 is finishing, that is roughing feed in Z, and F100 means roughing feed in XY. That means when it is going here, roughing feed in XY, that means in the XY plane. Okay, and B1500, J200, these are applicable for finishing. That's why it won't apply. Okay, that is why be careful. This S1000 is roughing spindle speed. R75 is roughing feed in Z. That means that is in the Z direction. Roughing feed in Z means it is in the Z direction. That is tool moving up and down. That is the speed is 75 mm per minute. F100 means that is feed in XY direction, XY plane. That is when it is moving, when it is creating this rectangular pocket, that feed will be 100. These things you will remember and write. After that it goes to safety position and home position and that is spindle stop, program stop and rewind and all that. These things we have done already. Okay. Now what we do is these things we will enter it in this Fanuc simulation software. Now we open a double click on the DOS box, then mount D:// you do, okay, then D:// you do, git D directory, then cd mill you do, okay, then Fanuc mill dot exe you do, Fanuc dot exe you do. It is an that means you are getting the simulation software. That means the screen of Fanuc simulation software is ready. Okay, now you see here, this is the thing, and if you put Alt Enter, this gets enlarged. I don't, I advise you to do, but I don't do because this cursor movement and explanation becomes difficult for me. That is why I don't do, but you do, Alt, Enter you do, so that this screen becomes enlarged. Now, as you know, here you have to enter the program, what I've done in session 1. What I've done in session 1, you have to enter the program. I've already entered, that's why you see here, I've already entered. Okay, this is the program. You see here, X160, Y160, Z30, billet tool 1, D04, tool 2, pocketing tool D08. Everything has been done already. Okay, whatever I explained there, it is all here. Same thing I've entered here. And even 172, 173, that is rectangular pocketing cycle. Can you see this, all of you? I40, J30, I told you length and breadth of the pocket. K0 is that corner roundedness. You take it as 0 so that you get almost a square, that is the pocket corner should be of almost a square rounded, so roundedness should be there. No arc and all that. Okay. Then P0 is a roughing cycle. Q2 is peak increment. R0 is the surface on which it has to operate. That is surface of the job. And be careful, this X0, Y0 will refer to rectangular pocket bottom left corner. So that this rectangular pocket will be at the center of the profile. Center of the profile. That is why this X10, Y15 will decide the center of the pocket. If you change it, it will get moved. Let us say X30, Y30 means it will move to some other position and the rectangular pocketing is done not at the center. You just calculate and put the X10 and Y15 so that it is at the center of the rectangular pocket. So you see here, Z minus 4 I made. Actually in the program Z minus 6. Now deliberately I made Z minus 4 because it takes too much time. 2, 4, 6 and all that. It takes too much time to do. That is why I reduced it to 4. You can do it even if you can make, if you have time, Z minus 8 you do and see how exactly it appears. The same thing can be loaded to any CNC machine and get the component. Now my depth of cut is only 4. In terms of 2 mm it will do. That is Q2. You can increment 2 it has 2 mm, then 4 mm. Okay. Actually in the program it is Z6. I have reduced it just to reduce the time. Okay. Now as you see here, I0, K0 is, since it is a roughing cycle, there is no base allowance and also side allowance also 0. P75, that means 25% overlap between successive parts. Okay, so that the finish becomes better. If I make P50, 50% overlap. Okay, P25 means 75% overlap. The finish will be much better. Anyway, I have given 25% overlap. Yes, 1000 means roughing spindle speed. Okay, R75 means roughing feed in Z direction. That is the tool movement. The tool movement in Z direction. That speed is 75 mm per minute. And F100 is actually it is roughing feed in XY plane. That is when it is doing the pocketing. What exactly is the feed? That is 100 mm per minute. Then this B that is B1500 and J200 will not be applicable to this problem. And better you write it. Anyway, it will not be applicable because we have made already P0. Already we have made P0 here. As you see here, P0. Okay. That is why that will not be applicable. Okay. Then after that, it will raise to 5 mm above and it will go to the home position as you see here. Okay. Now you see M05, M30. Now you take the cursor to the first line. Take the cursor to the first line and function F9, that is F9 you put. Check syntax you do. Your CNC program is okay. That means it says your program is okay. Okay, then what escape? Again F9 you put. For F9, try run you do. If there are any problems, immediately you will know. Try run you do. Here move exceeds limits. Move exceeds limits means there is a error here. What we have made, I tell you, you put escape. Okay, put escape. Take the thing to the, that is cursor to the first location. Okay, function F9 you put, set datum you put. The datum is here, somewhere here at the bottom. Now we will take it somewhere here. So that once we take it somewhere here, you will have, this is the positive value. This arc you will get, no. Since it was here, the arc you would have got negative. That's why it was showing error. Now if the 0 point is here, okay, this will be, since you have positive value here, you see here, this is Y30 is there. That is why it won't show any error. That job 0 point, you take it here, so that Y30, this amount is 30, actually this is 65 and all that. Okay, in that way it won't show any error. Now you just see this you do, then you show run program, you go. Run program, if you go, you see here, now yellow I told you, it is the tool coming from the home position, and this white is actually cutting. The cutting of the profile has already been done. Now it is doing the rectangular pocketing. Now you see Z minus 2. Z minus 2 it is doing. Now Z minus 4. Actually the program Z minus 6 is there. Since it is taking more time, I have restricted it to Z minus 4. Z minus 2 it will do, then Z minus 4. You see the tool, this is how the tool moves even on the CNC machine. You can see the overlap also. Okay, 70, you can see this is 75 means 25% overlap will be there. Can you see this? Between the first successive path and second successive path. Okay, 25% overlap will be there. Okay, 8 mm is the width of the, that is diameter of the cutter. Now minus 2 is over. Okay, then it becomes minus 4, you see. After minus 4, it will go to the home position. Now it is cutting. It will cut in the same way. It will go in the same path. Okay, same path it will go, and it will be doing the cutting. And as you should know that if the same program is entered on the CNC machine, okay, you should enter on the CNC machine, you will get the same profile on a billet of whatever you feed. Okay, you should initially calculate what is the size and all that. Since it is 60 mm and I have taken here 160 or whatever it is. Okay, you minimize the wastage of material. Okay, so that entire thing has to be done within the workpiece allocated here. Now you see a minus 4, it is done. It has come to the center. It will go to the home position now. It will go to the home position. The program is over. Program stop, and it will rewind. That means it will come to the first line. Okay, starting line. Okay, now you see here function F9. If you 3D view, if you see, and it is giving, and more or less it is all okay here. Okay, this profiling is okay, and rectangular pocketing is also okay. This is what you are expected to do in the exam. You do till this correctly. This is perfect. Now some bursts will be there because the overlap what I have given is only 25%. As you see here, the overlap what I have given is that is P75 I have given. Okay, if I make P50 or P40 and all that, if more overlap is there, this burst and all that cannot be seen. Anyway, this is the thing what I have told you. This you do, and you see here, if you want to save this file after having entered and all that, you see here, if you want to save, F10 you do, CNC files, save as, you do this, and 04 mm you do this. You see here 04 mm. I have saved it as 04 mm. I think you can see this 04 mm mill I have saved it. Then F10 if you see this F10 CNC files, if I say new, the screen becomes new. Okay, all have gone. Now what you have to do is, if you want to call back this, a function F3, do this, and wherever I have made mm, here it is there. I'll call this. You are getting back this, and you can recheck function F9. Your CNC project syntax and all that. Your CNC program is okay. In that way, you can do. This is why this entire simulation I've shown, and the same program can be transferred to the CNC machine, and you can get the component in the same way. You can adjust it to the center also by suitably selecting the datum. Okay, thank you very much for watching. We have come to the end of session 2 of problem 3. Thank you very much, students. Thank you very much. Thank you.